Yo guys, what's up? Here on site. Today we will be going to solve something new. It's on the topic of linked list. Till now we have completed three questions. They were so easy. We solved in few minutes. Now we are going to solve another easy question, which is this one. So, is why is there no option for practice? I want to practice question, man. I refresh it. Don't think so that this question is for practice under their plan. Why is it not there for practice? Okay, so not a big deal. We will solve it on code if I have not done it over there. Copy link address, just paste, move and node from the edge. This is the question. I have solved it or what? No, I have not. Cool. So should we first move on? Yes, we are here. So how we will be going to start this question? First of all, let's start the timer. Let's understand the question. Remove the node from end of the list. Quite simple. Even head of linked list, remove nth node from the end of linked list and remove its head. So here the second node we have to remove, first and second. So previously the question we had done, which one was find middle of linked list. Here the brute force approach was finding the whole length and iterating the half length, something like that. Here so we can use something like that where we can iterate the whole linked list. Its length is 1, 2, 3, 4, 5, and they are requiring us to do L minus 2. So 5 minus 2, which is 1, 2, 3, 4. No, 5 minus 2 is 3. So 3th node we have to remove. So this is the brute force approach. It might take, it might not. It will take O n. What will take O of n plus traversing till L minus n length. It will take O of L plus L minus n time complexity, and space complexity will be constant because we are using any auxiliary space or something to store our answer. So quite simple. Let's move on pen and paper and do dry run. Alongside, I will show you the optimal case. Okay, so I have fixed a framework for this where I have said that there are two attempts. I have done one attempt on my own. The second attempt goes on the live stream. So first is to try remember optimal. If you are able to remember it, give an attempt for it. If you are unable to do the check, check the dry run, understand the approach, then try to implement on your own. Still unable, see the code, mark it for revision or for again. So let's see what's going to happen today. So today is 10th of March 2024. This is our 26th sum. It is called remove and node from end of linked list. So are you able to see? Yes, most probably. You- Let's take the example 1, 2, 3, 4, 5. N is equals to 2. So let's again remember what was brute force. Get length of linked list, then remove L length equal to L minus N plus 1 node. In our case, it is 5 minus 2 plus 1, which is 4. Fourth node we have to remove. How we will do that is by reaching over here node before that, then just do this. If it is temp dot next is equals to temp dot next. Quite simple. So how would we begin? Here there are two base test edge cases. One, if n equals to 0, remove tail. If n equals to what's the length? N equals to the length of linked list. Remove head. So what we'll do is head dot next dot delete of tail. N not equals to 0 equals to 1 1. So let's go to the optimal. Before moving on, time complexity will be of O of L plus L minus space O of 1 constant time complexity. So optimal Here what we will be using is fast and slow pointer. It's not quite actually fast and slow pointer, but let us call it such a way. So how does this go is fast and slow pointer will start over here. Um, we will move fast until it reaches nth position from start. So first 1, 2 should it be here? So if it is here, now what will happen is fast and slow pointer jump until fast is just before null pointer. So next is pointing to null, which results in us getting the slow pointer to point at the step position. We don't want this. Our condition would be what will be our condition? If fast equals to null, return head dot. What does this mean? Is that this case that n is equals to the no the fast because the end node from the end is yes. So in this case we understand that they are asking to remove the first head pointer. So in our case fast will point over here, slow will point over here. It will keep on jumping until fast comes slow next. But here what the problem is, we want it, let's check the dry run. N equals to 3. Fast goes ahead. So it will come here for pointer here. 2 position na n equals to 2. Why are we doing this? So that comes over here. And now s dot next is equals to s dot next dot next. This helps in deletion. So here the same edge cases are prevalent. One being the length equal to n. So we will do next. And if it is tail, it might be satisfied in this only, this edge only. Move fast until we reach nth position from start. And here is happening is slow dot next is equals slow is equals to slow dot next. Same or fast is equals to fast dot next. But until what? While f dot next not equal to null. Quite simple iteration. Let's move on to the implementation, the big boy. But I didn't share with you the what we say time complexity. So how will the time complexity scenario? Since first pointer is iterating till the end of the array, let's use black pen. Time complexity will be since first pointer is for iterating the whole length and slow pointer is iterating the whole length minus the target of 2. Here it is also n, so how we will do this is we will take this l minus and we will take smaller n, but in if we approximate it is around O of n, space complexity is O of 1 maximum. Hmm. The phone quickly heats up, so I try to shut it down as fast as possible. So let's invent our optimal case. Explanation took 7 minutes. How we begin this? By initializing a point while n not greater than. So this is the edge case. Length of link is equals to n. Delete here. I feel the voice of surrounding is coming. So let's close the windows and jump into rock and rolling while fast dot next not equals to null. What we will do? What we will do? We will do slow DC first. list node. Hmm, while first word equals to null, first the next node equals to null. Return head. This was the question, man. Oh shit. So list node. The main logic I forgot. Delete node is equal to slow dot next. What are we going to do? Slow dot next equals why we are doing this delete null. Our it is our own logic for garbage collection. Let's go. We are going to rock it, man. Soupy doopy. In 11 minutes. Completed, lock and loaded. 100% zero mission. Happy from the outcome. Yes, I am. Let's now revise. Revision is the key, man. Where we had stopped it. Find the duplicate. Okay. Repeat and mix. Inversion of array. Count inversion, I feel. Or reverse pass. So find duplicate one, then find missing and repeating. What is brute force? Nested loop, keeping count equals to 2. It is repeating. For j equals to I. What is I? Repeating is equals to I, as if count equals to 0. Repeat missing is equals to 0. Okay, if repeating not equal to -1, and okay. So for every element we are looping through to check if duplicacy its value is duplicated or not. If it is, we will update it when getting out of the loop, and if both the values are updated, we will break it out using this condition. Okay, so what is the better approach? Using hashing means hash map. Mm, Let me remember. Repeating and missing. Or if okay, so just an array storing. the count. Then it is 2n, and also O of n is the space complexity. So optimal using math. Oh my god. Using XOR control copy link address. I have not solved this problem at all. Have I done this on Word? I have not solved this. I'm using my sibling pain in my ass. Remove. So what was the question? I have solved this. It's showing. See, I have done. So I have also used an array for set count index of 0. Okay, let's check the optimal tool. I know extra if the occurrence is duplicate, that value gets removed. I know this kind. So let's see what they have to find XOR of all elements. Find differentiating bit. What is this sign? Quite boring. What is the second question? Open in new tab. I have not done. Okay, login. Count inversion. Here the merge method. I have done this in our live stream. Where I have done it is the question. Most probably count inversion on is for the yes. So what is happening over here in every merge function call if ARR of left is greater than right means there is an interval. Are we calling this interval? No, no. So we are increasing count that in the recursive call, implementing it and sending it to the parent. Okay. Count inversion was quite easy. Here we have missed an optimal one. I don't feel I will be doing the optimal one. Search in 2D matrix. It's very simple. How we want to do is it's just what we say binary search where we will be using row by n and in column by mod of n, something like that. Copy link address, control V, mid by n. Yes. So and we have saved it m into n minus 1. N is what? N is the number of columns. So mid by n and here mid mod by n. Why here also we have taken n is a mystery. Okay. So the logic over here is the same. So if our array 1, 2, 3, 4, 4 to 3, it is 12. So end is 12, start is 0, and mid will become 6. So 4 with 4 means 0, 1, 2, 3, 4, 5, 6. So what they are doing, mid by n. So by n. What is n? N is 4. So 6 by 4 is 2. Matrix dot second, okay, second row, mod 4. Okay, mod 4, 6 mod 4. The remainder will be 2 again. So 0, 1, 2, 7 is it? 7 it is. So what is logic over here? It's quite interesting. So today I was solving in recursion the last question permutation sequence. There also logic was used where first they are using it to find the middle element, then they are using it to find the value among the array. Quite amusing. Let me show you where it is. So see the ky factorial they are doing. So what is ky factorial? Hmm, where is my notes? it is to find amongst which factorials. So there, what is 4? You might ask. Means what is k? So what is k? K index. So k means what I was going to say. K is index of the permutation we are searching for. So for the size, remaining size, the possible permutation are the factorial value. So 4 by 2 gives the subgroup of permutations, and after which k factorial, k mod factorial gives the within the subgroup which element we are searching for. So what is the next part? Repeat a missing number. वन डुप्लीकेट हो गया, ये भी हो गया, फर्स्ट हो गया, पावर ऑफ n. This is binary exponential something, exponentiation problem. Yes, I know. So the what we say, brute force method is to do, where is it? Brute force method is to simply 2 raised to n, no? So simply multiply 2 until n becomes 0. And if the n is in negative, we can do inverse. Then so in Java we will continuously do this. Here is not the inverse, but if the value is negative, we can do inverse over here, then divide by the answer. We can do it over here. Quite simple. Let me check my old submissions. Math.power, I did it directly. If n is less than 0, n into -1, see, after this we are doing 1 by 0. And we have to use over here double because of the decimal answers possibility. And this was at the same time, but it's not in reality, it's far better. Here it is O of n time complexity, and here it is not considering overflow thing, and here it is taking log at time. So how this goes is our, my family don't close the door when they leave. So the optimal case, we will do the again check, but if while O of n not equals to 0. Let me show you in pen and paper. Binary exponentiation over here. So negative power considered. If the length is even, we will decrease length the n by 2 and just multiply x into x. So what is happening here, if I illustrate with an example, if the value is 6, n equals to 6, and our x is equals to 3. So x becomes 3 into 3, which is 9, and we will decrease n by 2, which will result in n becoming 3. Why? While doing this is 3, because 3 into 3 is 6. 3 into 3 is 9. 9 into 3 is 27, and more 2. So we are reducing by 2 and increasing this by 3. And if it is odd, so here is an example. 2 raised to 5 n is equals to 5. 2 raised to 5 no, so 2 into answer, it would be 0. Then was early on 4, 4 to 16. Okay. This helps reducing that time complexity. I mean, why I was able to explain to you all. What have I written in below? N into 1. N and 1 is equivalent to odd, and the right shift is equivalent to n by 2. Okay, shift by. So let's see how Stripe is explaining in his video explanation.
Hi everyone, this is Trevor here. So today we are going to solve the problem power x comma n. So before starting off with this problem, if you are loving this placement series, please make sure you like this video, and along with that you share the series among your friends and juniors. So the problem basically tells you to implement power x comma n. So what does power x comma n does? It returns x to the power n. Now you might be given any value of x. It can be an integer, it can be a double. You need this negative integer cannot be stored in an integer. Basically, this is the edge case you need to take care. Whenever you're converting, you can take a long or a long, that is your wish. So what is the time complexity of this method? It is actually big O of n because you're looping from 1 to n, and it's a big O of 1 because you are not using any extra space. The interviewer will ask you to optimize your approach. Assume that you are given to find 2 to the power 10. So you're going to write 2 into 2 to the power 5. Now why can we write this? Because it's 2 to the power 2 and 5. That is what this is. And that apparently means 2 to the power 10. Now at the next step, we can write it as 4 to the power 5. So basically we see something. Initially our x was 2. So our x got multiplied with itself and our power got divided by 2. That is, it become 5. Now at the next step, you're going to find 4 to the power 4. Basically, you take one of the x outside. Now you know it's 4 into 4 to the power 4. So you'll try to find out 4 to the power 4. Discussed over here 60. Where got 256 into 256 to the power as 256 can be written as whenever the power was even, which will multiply the x into x to the power 0. Now you know can be right point of that is integer. Basically, a positive is the edge of this method. It is actually we go optimize your 56. So 4 to the and we can get back as apparently makes it an even number at the next when n is. So I've already discussed about this in the brute force approach. You can get back to that brute force approach and see what do I do when n is negative. Time complexity is logarithmic base to n because n is getting divided by 2 whenever it is even, and whenever it is odd, it is getting reduced by 1, which apparently makes it an even number at the next step. So let's
Okay, so since n is divided by 2, it's resulting in odd value. A log, since the value is divided by half, it is resulting in n by 2 complex. Okay. Power of and majority elements. So copy link address, control T, control V. You might not able to see. Coding ninja is on. Majority element. How is this goal being solved? So setting up a hash map containing the counts, then we will iterate the hash map and check if count is greater than max count. The count is equals to 0. So we are iterating and trying to find the element with the highest count. Okay, so what is the brute force approach? Okay, here the flag method might be used in optimal. That's flag method. Oh, voting algorithm. Okay. Where was flag algorithm used? For sorting 0, 1, 2. Okay. Voting algorithm I have a YouTube short form content for you all. Why is this not shifting? If I am on Brave, we are still looking at this. Brave, Brave, Brave. Chrome. I mean, I don't want to show you all my recommendations and all. Like videos where it is. What is that fellow's name? Red. Red. Four steps to solve any dynamic problem. reg, hog, voting, algo.
FANG companies seem to love this interview question. It's called top k frequent elements, given an integer array of nums and an integer k, and we want to return the k most frequent elements. So if we had k equals 2 and the numbers 1, 1, 1, 2, 2, and 3, well, the top occurring is 1, the second most is 2, so we return 1, 2. If we had n equals 6 numbers in the array, there's no way any number could occur more than 6 times. That means we could make an array where the index is the frequency. If you had 3 ones, well, we would put that in the 3 spot. We would put 1 right there. We have 2 2s. We would put 2 where the frequency is 2. And we have 1 3, so we would put that 3 in the frequency of 1. We can simply go backwards through the array and pick up the top k numbers. 1, we'll get 2, and that's our answer. But hold on, suppose this number was actually a 4. We would actually make this a list of 1 and 2 since they both belong there. So these are all going to be lists of numbers. And here's my Python code if you'd like to check it out. Fang?
Oh god. Oh my god, you weren't able to see the video. Like hot shots, latest common divisor.
Google, Apple, and Amazon all ask this easy coding question. The problem is called concatenation of array, and
Where are you, Dad? Oh, that is not dynamic. No, controller, drag. Why is this not being found? It is in my main account. Give me 5 seconds, 5 minutes. I mean, history.
we're told by society today that
Let it be Moore's voting algorithm. Majority elements. Brute force. Okay. I felt it was nested loop. In nested loop, counting if count greater than by 2, just return it. Okay. Better approach, keep hash map. Store all values. If greater than 2, just return it. Moore's voting algorithm. Nah, nah, bro. Let me search again because. Oh my god, why is OBS lagging, man? I don't know what it is. Majority element drag how to get ahead of 99% of business. Let's save for later. Let's do this. Build your own GitHub. Let's save this for later. Spring Master. Yes, I think so. I
I
found it.
personally hate this coding question, but Fang seems to love it, so let's do it anyway. The problem is called majority element, and it claims to be an easy problem. We're given an array of integers, and there will always be one majority element that appears in over half of the array's positions. We simply need to return what that element is. We can just make a counter. We saw 4 2s and we saw 3 1s, so we'd return the max element, which is 2. This solution also uses O of n space. Can you do it in constant space? The trick is to always keep track of a count of the current candidate, which is the first element. And when we see the candidate, which we do over here, we're going to make the count go up by 1. When we see elements that aren't the candidate, our count will go down. Over here, it's going to go down to 0. And so when we get to here, since the count is 0, we actually switch the candidate to be 1. And immediately, we don't see it here. So the count goes back to 0, and it's going to turn back into 2. And here's my Python code. Isn't it elegant? Drop a like if you think it's cool. I personally hate this coding question, but Fang seems to love.
Okay, so the question was quite simple. We are keeping a candidate count here, and this is the element which is candidate value. So if count equals to 1, we will do this reinitialize to 1 and set the current element, and we will keep on decrementing it if the element is not equals to the current element. If it is equal to, then we will increment count, then checking if the stored element is in majority. So okay, it is a double checking over here. For int I is equals to 0, if vi is equals to element count 1 plus plus. If count 1 greater than n by 2, return here, else return -1. Hamra majority elements n by 3 times. Okay. Oh my god, you are not able to see the code. This was the code for n by 2 times. N by 3 times also would be similar, so not waste time again sharing the screen. Keep count. If count equal, if greater than, just add. So there are multiple. Okay, done. Better approach, hash map, hash map, hash map, hash map. If greater than, if size equals to break. Why break? Mini equals to mini. What is ls? Why is it given over here? Please check. Okay, what I have done, copy link address, what am I going to do? Going to paste this over here. Okay, so let me go to my profile. In my profile, is it an easy question? What is the question? Majority elements. Okay, I might have done it on little code. What, when my screen was small, were you able to see the change? Chrome. Copy link address, go to Chrome, similar only I feel. Just I've used another loop for putting it. Bad choice. Now let's go on to Brave browser to see the optimal approach. Boyer-Morris voting algorithm. Count equals element 1, element 2. Count 1, count 2. If element 1 not equals, count 1 equals to 0. Else if count 2 equals, so this is again cross-checking part. And no, not this one guys, still here manually check. See, they are doing cross check, so they are using two count and candidate keys. Here the candidate is called element. If count equals to 0, we will reinitialize. If count not equals to 0, if count equals to 0 and element not equals to, so if this is an element here is not equals to the element current, we will jump over here. If element here and count equals to 0, then we will update. If count equals to 0 and element not equals to the stored one of element 2, okay, so we must not repeat the element. So I will write to define myself. If count 1 is equals to 0 and the same element is not present in element 2, we will update this count 1 and element 1. If count 2 is equals to 0 and element 1 not equals to v of I, so if count 1 is 0 and element 1 doesn't contain the current one, we will update count 2 and element 2. Else if v of I equals to element 1, we will increment count 1. If equals to count 2, we will increment count 2. If both are not equals to, we will decrement both values. Wow, quite simple. Guys, I'm exhausted. Now I will come on for the next problem after few hours. I mean, now it's 5 o'clock. Most probably I will come on 6. Let's see. So today's day was quite informative. We completed one question. Yes, we did. Which one was it? We did the remove, and now we will do this later on. And today till n by 3 we have revised from repeat and missing numbers. Yes, okay guys, bye. Thank you for being with me. I'm going to end the stream now.